Hey everyone, in this episode we will have another look at how we can extend hot chocolate in various ways. Today we focus on the resolver compiler and what we can do with it. It's another deep dive episode, so hold on to your seats. Before we get started, we are running workshops at NDC Oslo and NDC Sydney this year. So if you want to learn all about hot chocolate, strawberry shake or relay, join us there. If you want to find out more about the workshops, head over to the NDC website and check them out. And with that, let's dive into resolver compilers. This is a very simple query type that has just a single field here called hello. And typically such a GraphQL type is inferred from a C# type when we use something like annotation based. We don't have to infer it. You could specify it in SDL, or you could use the Fluent API. But typically when we use something like annotation based, we would infer from a C# type the actual GraphQL type. In C# we call the method hello here the resolver for the actual GraphQL field. And we infer from that resolver the structure of the field, like the argument is inferred from the parameter that we have, and the default value is inferred from the parameter's default value, and so on. But there are special arguments in our resolvers, like this service argument here, that are not inferred into the GraphQL type, because they are not meant to be part of the type. They are services or special state objects that we use to implement the resolver functionality. In this instance, we are using an attribute here to mark the formatter argument as a service, as a special type. So when we compile the resolver pipeline, we know that A, we don't want to have a formatter in our GraphQL type, and B, that this formatter shall be injected from our services. But there are like special things, like we could also have a formatter here without an attribute, and still the resolver compiler could know that this is actually a service and we have to inject it. And this is handled by something we call the parameter expression builders that inspect the parameters of a resolver and then decide if this is actually an argument value or if it's something special. Okay, let's dive into some code and see what we can do with the resolver compiler. So first, let's have a look at the project here. This is essentially one of the starting blocks for our workshop where we build a cryptocurrency marketplace. At this point, it's really the starting point here where we just have a single resolver, get assets. And assets are essentially our cryptocurrencies that we want to list in our marketplace or whatever. And we can see that our resolver here, get assets, has a single argument or a single parameter, asset context. And asset context is actually a DB context. We could annotate our resolver every time where we inject this service with the service attribute or whatever, and then this would get injected. But hot chocolate comes with a nice thing that is that we can register DB context with this schema, and by doing so, telling our resolver compiler that the asset DB context here is actually a service, or in this case, is actually something else than a service. It's actually a DB context. So we are also making clear to the resolver compiler that this is a special service. And we can also specify behavior here because we are using a pooled DB context. So essentially, we couldn't just inject the asset context here. We would need to inject a factory, the IDB context factory, create the DB context and dispose it at the end. So essentially rent it and return it. We don't want to do that in our resolver, so we just tell our resolver compiler that this DB context is pooled. And then the resolver compiler will generate code around our resolver that will resolve the DB context factory, render out the DB context, inject it into our resolver method, and at the end of it, dispose of it. So a lot of code is now reduced by the resolver compiler, and it's called resolver compiler because it really compiles. So we are building up expressions, and then the full resolver pipeline is compiled into a single delegate that we can execute. That is done on startup. So when you start up a hot chocolate GraphQL server, sometimes it takes a second or so to get up because we are compiling actually the schema resolvers. So at runtime, we have no reflection then anymore. It's just execute, execute, execute. So before we dive in deeper, let's just see that this is working. So we do a .NET watch with no hot reload. Okay, let's try that out and see if that works. It will work. We shipped it, we tested it, but still, let's just try a bit. So we just want to have the names here from our assets. We're executing it, and you can see there are a lot of assets coming. And if we look at our resolver, it's really, really simple. There's no renting the DB context or whatsoever. We just say we want it, and the resolver compiler will now take care that it's injected in the way we have defined. Okay, so what we want to do is introduce some state here. So our goal is, if we are logged in, then we want to display all of the assets. So the user is allowed to retrieve all the assets from our assets resolver. But if we are not logged in, then we only want to show the first two as a demo sample for not signed in users. So how would we approach that? So there is something we call state in hot chocolate, and there are various kinds of states. There's global state, scope state, and resolver state. And we could use that to maybe store a user in our state. And then we could figure out what to do with it in our resolver. In order to inject state, the resolver compiler already knows how to inject state. So we could, let's start simple with a user ID. So we could go here and say, we want to have global state. And this global state is actually just an integer and is the current user ID. So what this does is injecting from the global state a user ID if it's available. If not, we get null here. And then we could change our resolver here to check if the current user ID is null. Then we actually will just return the first two items, two assets. Okay, otherwise we return all the assets. So we would need to enrich the request with some state here. So in order to enrich our request with some global state, we could introduce here a request interceptor. So we call this the custom HTTP request interceptor. And let's bring that in. Okay, so this is the base structure of the interceptor. We are using the default HTTP request interceptor. And then we could inject here state. So state is injected by using the request builder. And then we could say try add property. The naming actually is here inconsistent because we call that adding a property, but then we call that in the resolver's global state. And then it's also called context data in some cases. Tobias, one of our core members, actually cleaned that up for version 13, while you still could use these inconsistent named helpers here to fill up state. They are marked as obsolete in version 13. And we now have a very consistent naming. So thank you, Tobias. Okay, but in our case, we could enrich here the state with the current user ID. and then put in an ID. And you can see here that the current user ID matches the state that we added here. So this is how it would inject. But that is kind of not so nice, because now we have to annotate this always. And if we maybe want to rename that and have a different name for it, we would need to provide the key here. Just so you know. Okay. So how could we get rid of that? Actually, we want to use this in this case. Actually, we want to have something more awesome, but let's just stick with that for now. So we want to do this. And there is something that is called the parameter expression builder that we can use. And they essentially are the basis for the resolver compiler inspection of the parameters. So what we will add here is one of those expression builders. In order to provide an expression builder, we need to inject an parameter expression builder. And we already have prepared one that is very easy to use. And that is the custom parameter expression builder. And there we could say, okay, we want to inject an nullable int. And the expression to create this nullable int is to use the resolver context. And from the resolver context, get a global value that is an int, a nullable int, and is called the current user ID. So this is now in. We have our request interceptor, and that provides us here state. And let me just hook that also up, because the request interceptor, we need to register it at request interceptor, and it's called the custom request interceptor. Okay, so this is coming back up. Let's go over here, execute that. You can see we have all the assets. And if we get rid of this guy here, we get only 2. That works. Our resolver compiler is now extended and injects now in every nullable int argument the user ID. That's actually not what we want. So let's refine that a bit. Actually, we only want this special parameter, which says current user ID, to be injected with the user ID from our global state. So let's go to our program CS here. And we actually can give our custom parameter expression builder here a second argument. And that is a delegate that gets in a parameter info. And then we could say the parameter info actually has to be named current user ID. And then we can go back to our query here. And let's just, for the test purpose, have another int here. Let's call that first, for instance. We don't need it, just so that our resolver shape changes a bit. So we refresh that, and you can see the shape changed. We now have to pass in first, which is 1, and still everything works, because we are only trying to inject the current user ID state into parameters of the type nullable int that are named current user ID. Okay, that works. Let's take it a bit further, because this is kind of not where I want this to go. So the current user ID might be fine, but actually maybe we want to have a user here. So actually we want to inject a user object. And we already have here in our DB context a user object. So we could take the user ID that maybe comes from somewhere else. We could take that, resolve the user, and then inject the user into our resolver. So how would we approach that? So this is very nice if you have simple things, because you actually can say, I have the state object and inject me that. But what I proposed here is actually something like the register DB context, where we might need to aggregate state around our resolver. So essentially, we need to create a middleware around our resolver. So for this, we are creating a new class, and we call that class the current user parameter expression builder. Not very inventive, but you know. And then we're gonna inherit from the custom parameter expression builder class here without generic. And that gives us two methods that we need to implement. The build method, which builds the expression for the resolver compiler. And we also get a can handle method here, which defines if this parameter is what we want to handle something for. You can see also we get the resolver context here, but we get it as an expression. So we can build with it our expression. So let's customize it a bit. So the first thing that I'm going to do is add an expression up here. And we are using a lambda expression, so it's easy to define it, where we say this lambda expression has a resolver context coming in and has a user object coming out. And the nice thing here is that it's very easy to produce a lambda expression. You don't have to know a lot about expressions here. You can just write as if it were a delegate. Okay, the second thing is we are implementing our build method here, and we are using the expression invoke here since we're having a lambda up there. This gets then compiled into the resolver pipeline. Last, we need to identify what parameter we want to handle. So we say all the parameters that are of the type user we want to handle. So in this case, we have a distinct state type that we want to always inject the current user into. Okay, lastly, we want to have a middleware around that. And there is a second interface, and that's the parameter field configuration interface that we can implement additionally. And it allows us to apply configuration to all the fields that have such a parameter. And you can see we get the parameter here, and we also get the object field descriptor from the descriptor API of Hot Chocolate. And this is just the Fluent configuration API of Hot Chocolate. Okay, so what we need here is actually a middleware. And that's the first thing I'm going to add here is the middleware structure. So we use the descriptor, and we say use. Just before we dive into that deeper, there is an episode on middlewares to understand what they are, what you can do with them. So if you want to know more, or you don't understand what a middleware actually is, go and watch that first and then come back and continue on here. We are using this middleware now, and this is wrapped around our resolver. And at the moment, we are just invoking next, and next could be the resolver or the next middleware in the chain. So the next thing is that we want to resolve our user here. So we have already the state, we have already the user ID in our state, but we're gonna resolve now our user with it. And this works by, if there is already a user in our context, then we will just take that user from our context. If there is no user in our context, we will check if there is a user ID in our context. If there is a user ID in our context, we clearly have to resolve a user for it. So we then will take the DB context, and we'll get it here with the factory. You can see that. And then we resolve the user ID for this ID that we have in our context and store this new user on the context. And then we will invoke next. And you can see in our expression up here, we're actually not resolving the user ID, but we are looking for this user in our state. So now, if we go back to our resolver here, and actually it's a nullable user, so it can be null if there is no user, we now can ask for the user in our state, and then could also do other checks with it. So this would work. We couldn't observe that actually there is a user resolved. So that is why I now introduced a new resolver here, and I'm calling it the current username, which actually is nullable. Here we also inject the user, and then from the user, if it's there, we take the name, just so we can verify that everything works as expected. So at the moment in our request interceptor, there is no state. So we didn't add the user ID here. So if we run that, we should get just the 2 items that we are allowed. And the new field, current username, should be null. Let's try that out. Let's just check if everything compiles. Yeah, everything compiled. So we go in here. This first argument is no longer there, so I removed it. And I can just execute that, and you can see everything is there as we expected. We don't get all the assets because we don't have a user. And if I have my current username field here, let's get rid of that guy and execute that, I get null. But the moment I enable the state here, go back into banana cake pop, rerun that, I can see that I now have a Nick here, which clearly is a user for the ID 69. This is awesome. Now we learned how we can use the resolver compiler not only to inject certain things into parameters, but also how it could apply additional configuration to our fields. Let's take that one step further. And so there's a third category here of resolver compiler extensions. And actually that is much simpler in version 13 than it's with version 12. But I'm looking today at version 12 so you can use it. And that is, if you already have a middleware, like let's say you're adding here middleware like use paging, and then this middleware produces some state, some additional state, then this state could be injected into your resolver. Think of that as local aggregated state that you only are able to inject when this middleware is on top. So for this last trick, we will duplicate our resolver here and say there is a current username 2, and then we want to have middleware that is called UseSuperUser, and that we want to put on top here. UseSuperUser, and then we don't want to have Nick as a user here, but we want to have Michael as a user. So let's have a look at how we can make that happen. So the first thing in order to build a middleware, and again, watch the middleware episode, is to create a object field extension. And we do that by introducing a new static class, object field extensions here. I already built that. So I'll walk you just through it. So up here, you have the expression builders that shall be applied to the field you are annotated to. So you can see that this expression builder will get local value, so local state, resolver state, and will get the state with the key user. Second thing we have is that we have here an extension of the iObject field descriptor. So you can chain in the UseSuperUser method now in your Fluent configuration. And what it does is it creates a new middleware that sets to the local state value here the user Michael. It doesn't override the global state. So it just produces state for the resolver pipeline. Okay, then we have this special thing here, descriptor extend, and that allows us to hook into the type initialization event. And in this step, we are hooking here into the on before completion. And that allows us to, before we complete this field, we want to change something. And what we want to change is we want to do the resolver compilation on our own. So we'll take from the context the resolver compiler, and then we compile the resolver for this field by ourselves by using the resolver compiler here. And we are injecting these additional parameter extensions for just this single compile into the resolver as well. These local expression builders will take precedence before all the global injected. Okay, last step here is adding our attribute so we can annotate, and this attribute will just intercept the configuration again for this field that we annotate and then apply this UseSuperUser configuration to our field. With that, is it compiling? Save it, wait for it. Yeah, it compiles. So this should still work. We get Nick here. But if we use, and let me refresh our schema for that. If we use current username 2 here, you get Michael. That was the last example I wanted to show you. I know that was quite abstract. So this is really an advanced topic, and not everybody of you will need to use that. That's really if you want to build extensions, or if you want to really simplify your code base and get rid of a lot of attributes. And with this, we are done. I hope you enjoyed this deep dive into the hot chocolate core. Until now, that was our secret sauce. With version 12, we now made it public. There's no documentation on it. So I made this video. It's still, I consider it an API for people that want to build extensions or that want to simplify their code base a bit, but it's not for the everyday user. So it is a bit complex, but it will get a lot simpler in version 13, where I guess it could become mainstream. We will see. If you like our content, please hit the subscribe and like button below and help us grow our project by starring us on GitHub. And with this, see you next time.